shed free tooth in your hand. Oh, sweetness.
Section 5.2 is on rate of change. Whoa, rate of change. And what rate of change is? It's a ratio that compares qualities with different units. So we've talked about ratios before. A ratio is just a comparison, but a rate is a special type of ratio that has different units. So for example, if I compare the number of boys and girls in the class, let's say the ratio of boys to girls is 3 to 2. That is not a rate, because even though it's boys and girls, we're really the same thing. They're students, right, that we're talking about. If I compare shapes, the ratio of triangles to circles is 7 to 9. Again, that's not a rate, because we're comparing two things which both belong to the category shapes. But if you look at something like speed, or how about distance per hour? Well, those things are completely different, distance per hour. Or how about hamburgers eaten over time? Those are completely different things. So these are examples of rates. Alright, we'll do some more examples in a second. First of all, the way you calculate a rate of change is exactly the same way as you calculate slope. And what you might remember is the way you calculate slope, and hence the way you calculate rate of change, is you do delta y, change in y, over change in x. Remember what delta means? This triangle here, it means change in. So the other formula we had was y2 minus y1 over x2 minus x1. This is how you figure out rate of change. Slope is just a type of rate of change. So here's our first question. At 1 p.m. Tracy had finished 12 of her homework questions. At 1:40 she was finished 30 of her questions. What was her rate of questions completed per minute? Okay, well, the way we get our rate is we want to know the change in y over the change in x. And what we're looking at is number of questions, so the change in questions over time in minutes, so change in minute. So what's the change in questions? Well, she was at 12 and then she ended up at 30. So we could do 12 take away 30, or let's keep it positive, 30 take away 12. That's the difference in questions. What's the difference in minutes? Well, it was at 1 p.m. and then it went to 1:40. So it looks kind of funny, but I guess you could say 1:40 take away 1 o'clock. It's kind of weird, but 30 take away 12 is 18. 1:40 take away 1 o'clock equals 40 minutes. So our rate of change is 18 over 40. If you take your calculator and actually do 18 divided by 40, you'll get 0.45. And what was on top, remember, was questions. And what's on the bottom is minutes. So it's 0.45 questions per minute, not minutes, per minute. This is your answer. She doesn't even finish half a question every minute. But hey, these are hard questions. Okay, the next question is, what was her rate of questions completed per hour? So up here we answered per minute, now we're going to answer per hour. Well, again, rate is equal to number of change in questions, sorry. But this time it's going to be in change in hours. Well, the change in questions is going to stay the same thing. It's still 30 take away 12. The change in hours, well, it went from 1 o'clock to 1:40. So 40 minutes. How much of an hour is 40 minutes? That's 2/3 of an hour. So what you end up with is 18 over 2/3. Now you could pick up your calculator and do that, but let's just remind you how you do this without a calculator. This line right here means divide. So what you would do is 18 divided by 2/3. Now, how do you divide fractions? Well, first of all, let's make them both fractions. So this is 18 over 1. And then what you do is you multiply by the reciprocal. Flip the second one. Like that. Okay, now you're ready to multiply. Multiply across the top, multiply across the bottom. Or if you want, you could simplify first. 2 becomes 1, 18 becomes 9. Oh, I've got my answer. My answer is 9 times 3 is 27. And we're looking at questions per hour. 27 questions per hour is our answer. That's her rate. Okay, notice in both of these two things, we're comparing completely different things. Number of questions answered and time, or minutes. Number of questions answered and time in hours. Those are completely different, so that's what makes it a rate and not a ratio. I mean, it is a ratio, but it's a special type of ratio called a rate. Okay, oftentimes you graph rates of change, and when you graph them, the quantity that's in the denominator is put on the horizontal axis, so that's put down here, and the quantity that is in the numerator is put on the vertical axis up here. So a taxi driver charges a flat rate of $5 plus 50 cents per minute driven, and we're going to write a formula first of all that describes this. Okay, so what we want to know is what's the total cost, right? I guess I should have written that. But basically we're looking at what's the cost. So let's put C for cost is equal to. Now, I know this is weird, but let's just say you got in the taxi. He started the meter and you immediately said, that's it, I want out. Didn't even drive a second. As soon as he started, he said, I want out. Does it cost anything? Yeah, it does. It still costs $5. That's the flat rate. So no matter how much time there is, you always have to pay a cost of $5. But then you're going to have to pay even more. How much more do you pay? You pay 50 cents, but don't write 50 here, because then that looks like $5 plus $50. No, we want 50 cents. So rather than putting 50, we put, how much is 50 cents out of a dollar? 0.5 or 0.50 if you want. 50 cents. Now, if you drive 1 minute, it'd be 0.5 times 1. If you drive 20 minutes, it'd be 0.5 times 20. If you drive an unknown number of minutes, let's call it t for time, you go 0.5 times t. So this is your formula right here. C equals 5 plus 0.5 times t. Alright, now we're going to graph this function. So time almost always is going to go on the bottom, okay, on the horizontal axis. So we're going to put time down here. And I don't know, let's go up by 0, 1, 2 minutes, 3, 4 minutes. You can put 1, 3, I just want to write every second one to speed it up. So 10, 12, 14. And let's put in brackets minutes so we know we're talking about minutes, not seconds or hours. And along this axis we're going to put the total cost, and that'll be in dollars. And I guess here we'll skip and go $2, skip and go $4, skip 6, 8, 10, 12, 14 this way. Alright, so at time 0, that means like when you first get in the cab and no time has passed, how much do you owe? You owe $5. Okay, now after every minute you owe another $0.50. Or the way you could do it is after every 2 minutes you owe another $1. So after 2 minutes you owe another $1, you're up to 6. After 2 minutes you're up to 7. Another 2 minutes you're up to 8. After 2 minutes you're up to 9. After 2 minutes you're up to 10. After 2 minutes you're up to 11, and after 2 minutes you're up to 12. There you go. And what we do is we join this with a line. This is a nice linear relation here. Makes a line, right? Okay, and of course it doesn't actually stop there. We could keep going if we wanted to, make the graph bigger. So you could put a line like that if you want. Don't put an arrow on this side. Put an arrow on this side if you want. Don't put an arrow here. It doesn't go down forever. It stops right there. You can't go less than 0 time. How much is owed after 5 minutes? Okay, there's 2 ways you could do this. One way is you could look at the table, right? You could go over to 5 minutes. You could look up from 5 and then over from there. And it looks like it's somewhere around 725, 750. But notice there's a certain amount of uncertainty if you do it that way. So another way, it is great if you just have the graph to do it that way. But the other way you could do it is you could use the equation. If I want to know how much it costs after 5 minutes, 5 minutes is a time, so I could put into the t 5. So I have c equals 5, I'm just copying this, plus 0.5, but instead of t I'm going to write 5. So I have 5 plus 0.5 times 5 is 2.5, and when we add that we get 7.5, which is the same as $7, and 50 cents. And I believe that's about what I said, isn't it? Yeah, I said 725, 750, and I was right. Okay, when is 850 owed? Well, again, you could use your table. You could go up to 850, which is right around here. You could go over to the line, and then down from there, and it looks like it's going to be at 7 minutes. Want to make sure? Let's use the formula. So 850 is the cost, so that's actually going to go where C is. 850 goes into the cost, equals 5 plus 0.5 t. I don't know what t is. So now I have to solve this equation. We'll get more into solving equations later, but you know how to do this? You got to get the t by itself. So the first thing we need to do is we need to subtract this 5. Subtract 5 from both sides. So that leaves us with 350 equals, this is gone, right? 5 take away 5 is gone. So it's equals 0.5 t. This means 0.5 times t, so we do the opposite. We divide by 0.5 and divide by 0.5. So you end up with t on this side because these are gone. 0.5 divided by 0.5 is 1, and that's what you want, 1t. And 350 divided by 0.5 is 7. Hey, what do you know? We were right. The answer is 7 hours. 7 minutes. 7 hours in the cab and only have to pay $8.50? This would be awesome. 7 minutes is the time that it would take. So 7 minutes. Alright, one more question and we're done. A bathtub holds 250 liters of water. After the taps are open, there are 15 liters of water in the tub after 45 seconds and 25 liters in the tub after 1 minute 15 seconds. Determine the rate of change. Alright, rate of change we said was equal to change in y over change in x. In this case, it's the change in water over change in time. So how much did the water change? Well, you could actually you could do this in a bunch of ways. You could look from the time 0 when it's first opened up to 45 seconds. You could look from time 0 up to 1 minute 15 seconds, or you could go from 45 seconds up to 1 minute 15. I'll do that latter case. I don't know why, but since they gave us all this information, I might as well use it all. So the change in water is 15 liters and 25 liters. So 25 minus 15. Now with the time, it goes from 45 seconds up to 1 minute 15 seconds. I think a better way to do this might be to do this in minutes, because we're not really interested in the change in water per second. I mean, that's not going to be very much. We're interested more in how much water change there is in minutes. It seems more sensible. So how many minutes is this if it goes from 45 seconds, which is 3/4 of a minute, right? Maybe I'll put that 3/4 or 0.75 of a minute, to 1 minute and 15 seconds. Well, that's 1 minute and a quarter, 1.25 minutes. So it would be 1.25 minus 0.75. Or if that's too confusing, just think of it. 45 seconds to a minute 15. How many seconds is that total? 30. And how much of a minute is 30 seconds? Half. We should get half on the bottom. And you do. 1.25 take away 0.75 is definitely 0.5. On the top, 25 minus 15 is 10. When you divide 10 divided by 0.5, you don't get 5 or 2 or something like that. You get 20. So the rate of change is 20 liters per minute. Alright, now we can use this to solve these questions. How much water is there in the tub after 8 minutes? Well, if there's 20 liters comes out every minute, then in 8 minutes, how would you figure that out? You just multiply 8 minutes times 20 liters per minute. Do you see how the minutes cancel? Because you have 1 minute in the top and 1 in the bottom. That's perfect. Because then what we're left with is 8 times 20 is 160, and we're only left with liters, and that's what we want, 160 liters. Okay, how much time is needed to fill the tub completely? Well, the tub was 250 liters, and we want to know how long it would take to fill, and we know 20 liters goes in every minute. So what do you got to do here? You got to divide. You're going to do 250 liters divided by 20 liters per minute. 250 divided by 20 equals 12.5, so it's 12.5 minutes. The liters would cancel because when you divide, it flips and it would become in the denominator and the minutes would be in the numerator. Don't worry about that too much. Anyway, 12.5 minutes is our answer. Alright, kind of a strange little section here. Bunch of word problems involving rate of change. Not the most important section, I would say, but do your best. The main idea that we're working towards here is that slope, which we talked about last time, is a rate of change, and this is why we have to get familiar with rate of change, because we're going to spend a lot of time talking about slope. Alright, that's it, and good luck with the homework, but we can do it in class.
Big mouth,